Transformers play a crucial role in electricity distribution network for delivering power to end users or customer. Distribution transformers are one of the critical and high-value capital expenditure asset for any discoms. To ensure profitability for a discom, it is critical to make DT as a profit center. It is estimated that out of 15 to 20% national average AT&C losses, at least 3 to 4% comes from technical losses in distribution transformers. Distribution transformer failure rates is one of the important key performance indicator for Indian discoms in India. 12 to 15% DTs fail every year, and the average rate of failure of aluminium wound DTs is more than copper wound DTs. The root cause of this are cited as overloading, short circuit, and unauthorized use. DT failure causes unplanned outage, revenue loss for utility, production loss for industries, and financial loss for economy. Realizing the need to improve the life of DTs, various possibilities are explored, and one among them is through better quality repair practices. International Copper Association of India, a non-profit organization, proposed a proof of concept to TangentCo, focusing on developing a mass replicable approach to undertake repairs of old legacy DTs. A team of researchers from ICA India, its design experts TriStar Technologies, and R&D personnel from TangentCo, along with highly skilled repairers from Shakti Transformers, jointly made this study to bring down the losses, thereby improving the efficiency and life expectancy of the old aluminium wound distribution transformer. Step-by-step approach was adopted during the repair execution, which ensured checks and validation at each level. A 100 kVA failed and repaired transformer that served for 10 years was provided by TangentCo. The baseline measurement of DT proved huge variations in both no-load loss and load loss. The recorded percentage deviation from GTP values of parameters were: no-load loss was 82% higher, load loss was 17% higher, total losses were 26% higher. ICA India, after initial benchmarking, submitted a revised design option to TangentCo. Once the design was approved by TangentCo, the transformer was dismantled and the aluminium wound coils of the high voltage side were replaced with copper as per revised design. Care was taken to maintain the impedance of the transformer and was continuously monitored at every stage. During this process, the transformers underwent both pre-repair and post-repair testing and enhanced performance testing. It was done at NABL accredited lab in the presence of TangentCo R&D officials. The testing results comprised of losses and temperature rise measurements as per the IS standards to establish benchmark levels. The output of performance-based repair, namely active repair, revealed significant improvement both in terms of reliability and efficiency. Active repair does help in technical loss reduction compared to baseline values. After a detailed study, the DT was erected, commissioned, and continuously monitored for its performance in Chengalpattu Distribution Network area. The results observed were reduction in copper loss, a substantial temperature drop in high voltage and low voltage winding, drop in top oil temperature. The results proved that proposed active repair practice will enhance the performance of old legacy DTs both in terms of reliability and efficiency, closer to energy efficiency levels specified by BIS standard IS 1180. Energy saved was to the extent of 4,000 units in one transformer per year, which means approximate of 20,000 per DT in a year. Also, DT capacity enhancement showed signs of improved reliability and creates approximately 10% capacity reserve. A increased life expectancy of the transformer due to the substantial drop in temperature rise. With key assumptions based on current market trends, the cost-benefit analysis reveals that only in 100 kVA, DTs have a potential opportunity for saving nearly 200 crore per year. Besides quality DT repair infrastructure, this project's scope also enhances the skill of local manpower for undertaking repair of a critical distribution asset for the utility. It provides opportunities for repairers with available plant and machinery. Copper displays low levels of creep. Under the extreme loading, creep rates of aluminium can be up to 25 times higher than for copper because of electromechanical stress due to short circuit clearance and temperature conditions of distribution transformer windings. This results in aluminium wound distribution transformers having a higher possibility to failure than copper wound ones. Copper wire terminations are less prone to failure than aluminium wire terminations. A key reason for this is the different behavior of their oxides. Further, copper is 100% recyclable, thus ideal for sustainability and retains its commercial value even after end of its life cycle usage. ICA India have successfully executed the exercise of DT active repair concept already in states like Maharashtra and Madhya Pradesh.